Coffee. It's a household staple. Millions of people drink it every day and appreciate its rich and bitter taste, excellent aroma and energising properties. Maybe you're one of them, but do you actually know what's in your cup? Well, let's find out. There are 1,000 molecules in coffee, most notably caffeine. This molecule tends to get the most attention and is responsible for the stimulating properties of coffee. This is how it looks to us. And this is how it looks chemically. You've likely seen molecules similar to caffeine before, but with less complex skeletal structures. Take a minute to familiarise yourself with caffeine by pausing the video and working out its molecular formula. But the star of our show is caffeic acid, and it's not just found in coffee. It's present in thyme, cinnamon, star anise, sunflower seeds and apricots, to name just a few. It exists as a yellow solid and acts as an antioxidant and anti-inflammatory agent. Research shows that it could potentially be both an anti-cancer drug and a carcinogenic substance, and it's worth noting that it's currently listed as a potential carcinogen. So here is our 2D skeletal formula. And here it is in 3D, built with a molecule kit. So if we delve a little deeper and really think about what this bunch of atoms actually is, we can identify the functional groups. So here we have a carboxylic acid, here we have an alkene, here we have an aromatic ring, and here we have two alcohol or hydroxyl groups. So far, we've just looked at the structure of caffeic acid and picked bits of information out here and there. But what's the point? Well, what if we didn't know what caffeic acid looked like? Or if we were given a sample of an unknown solid and asked to identify what it was? We'd use spectroscopic techniques to produce a spectra of the sample, which we would then use to work out the empirical and molecular formulae and the functional groups present within the structure until we came to a sensible deduction of what the solid was. Let's try it with caffeic acid.
So, C9H8O4. We'll run through it. I'm gonna draw all the carbons in. 1, 2, 3, 4, 5, 6, 7, 8, 9. C9. Then hydrogens. Well, some of them are already drawn in the structure. So I'm gonna put additional ones here, 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 and then one here and one here. And then let's count them. 1, 2, 3, 4, 5, 6, 7, 8. That's correct. And then what we're left with is oxygens. 1, 2, 3, 4, 4. Ta-da! Now let's have a look at an NMR spectrum. So here you have a spectrum of caffeic acid. Remember, it's a real molecule, and therefore some peaks may be in a slightly unusual space to what you have in your data sheet here. This one is taken from OCR exam board. Firstly, let's have a look at the scale of this spectrum. You can see it starts at 6 and finishes at 8. That's because there is nothing outside this range and no peaks there. Secondly, let's look at the number of peaks. So we have one here, second one here, third one here, and this part has two peaks very close to each other. So there are 5 peaks. If you remember, our structure was C9H8O4, but we only have 5 hydrogen peaks. Why is that? Well, we have 3 OH groups, and the peaks for OH can be very broad and appear in many places of the spectrum. So we can just get rid of these peaks by using deuterated water that exchanges with the OHs to form OD instead of OH, and then it's just not visible in the spectrum at all. Secondly, we can look at the spectrum and try to identify some of the peaks. We're going to focus on just one of them. Here at 6.7 ppm, we can see an aromatic proton, which is a doublet, 2 peaks of the same intensity, and it has integration number of 1. That means there is only one of them in this environment. And if we look here in our spectrum, there is a hydrogen that only neighbors one other hydrogen, and it is an aromatic one. So our spectrum agrees with our structure.
Let me end the video with a fun fact. Caffeic acid can be used in the development of black and white film photography. If you want to try this yourself, just search Caffeinol on Google and remember to follow the safety instructions. Now it's time for my coffee.